Okay, I'm going to split U2A3 up into two videos. One's going to be called Electron Configuration and the other one's going to be called Quantum Numbers. I notice when you go through the material, they tend to meld the two together and overlap, and I'm just going to put them in as two separate things. I'm going to spin my tires a little bit here, and then I'm going to come back to what it is that you need to be able to know. So basically, I'm going to go back to a Bohr-Rutherford diagram, and I think I'm going to do oxygen. So when you're in grade 9 and you do Bohr-Rutherford diagrams, what we have to know is we have 8 protons, we've got 8 electrons, 16 minus 8 is 8 neutrons. And so I'm going to put my protons in the nucleus, put my neutrons in there, and I'm going to start adding my electrons. Now the Bohr-Rutherford diagram came about through McGill University. It was one of the players, and it was just trying to show us what an atom looked like. So when you put your electrons in, 1, 2, 3, 4, then partner them up. This has to do with quantum mechanics. I won't get too deep into that right now. But as you go on in life, models evolve and models get better. If you just want an analogy there, take a look at cars. Cars are still cars, just like atoms are still atoms. We just get more and different varieties that have where the model actually evolves and gets better. So we've gotten better with the models that we use. You're going to learn something called electron configuration. There are models better than this right now, but this is the jumping point off to really understanding things. Basically, what we have here is we have a nucleus and we have energy levels. Energy levels get the symbol N, and an energy level is a distance away from the nucleus. So we have that energy level and we have that energy level. Now what we're going to do is we're going to get away from the Bohr-Rutherford diagram. We're going to do oxygen. I'm going to show you a couple of things that are important. So first of all, you must know that oxygen is the 8th element, and once you know what element it is, once you have the atomic number, you start using this thing called a filling diagram. So copy this out. You're going to use this over and over and over again. So the first thing you're going to do is fill 1s. This is called the Aufbau principle, starting from the bottom up or starting from the beginning. S orbitals have 2 electrons in them. Okay, so it's 1s2. I'm going to draw a diagram when I'm done here. This is the actual electron configuration. I'm going to draw something you won't need to draw. What comes after 1s? It's 2s. S holds 2 electrons. How many electrons do we have now? In the first energy level, so in the first energy level, we have 2 electrons. In the second energy level, we now have 2 electrons. Where do we go next? We now go here. So you just keep filling these arrows, or following these arrows. That's A, that's B, that's C, and every element is the same in that you always start from that same point. You start from the beginning and you keep going. So, p orbitals can hold 6 electrons. We are in 2p6. Okay, so we're done. This is an electron configuration for oxygen. 1s2, 2s2, 2p6. 2, 4, whoop, I went too far. We only need 4 of those electrons because we only want to go to 8. 2, 4, 8. So let's draw a box diagram of this. So when we draw s orbitals, they look like this. It has 2 electrons. The electrons have opposite spins. You're not going to understand all the detail here. You just have to know how to draw the box diagram. That's 2 electrons. And then we have another s orbital, 2 electrons. And then we have a p orbital. P orbitals have 3 boxes. Everything comes in 2s when we're doing this. So 6 maximum altogether, 6 maximum in a p orbital, 3 boxes, 6 divided by 2 is 3. You put 1 electron in each box. There's 3. And then you start partnering them up. It's important that you put them in that order. Put 1 electron facing up in each box and then put another one in. I'm not sure if they're going to ask you to do these orbital diagrams or not, but I thought I would show it. Here's the diagram that you won't have to do. What does this actually look like? You have 2 electrons in an s orbital. That's 1 s2. You have 2 s electrons in the second energy level, and then you've got your p orbitals. Now, this is one orbital. See this crazy diagram? This is one orbital with 3 suborbitals. Okay? 1, 2, 3, 4 electrons. Doesn't matter where they go in there. Hey, what you're going to see is that these electrons are flying around at the speed of light. A ray of light can get around the Earth several times in 1 second. So you can't actually isolate an electron to one spot because they're moving so quickly we can't see them. What you can see here is that this diagram is way more complicated than this. You'll see something in your content called probability diagrams, and these are probability areas. It's the area where we're most likely at any one time, if we were to stop time, where we would find the electrons. Okay? Let's try something a little more complicated. We will not go to the F's. D's can hold 10 electrons. So where the P's have 3 sublevels, the D's have 5. So we could put a maximum of 10 electrons in here if we needed to in the D's. But we are not going to go to the F's, but your order of filling looks like this. Okay, so that's as far as we're going to take it right there. I'm going to do vanadium 23. So if we go back here, we're going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d is where the vanadium is. So all you do is start adding in from the beginning, just follow that chart until you get to the vanadium. So you should go back and check what I did to make sure I did this right. And the vanadium is the 3rd one in. If you count up all your electrons, you should hit 23 electrons. If I wanted to do box diagrams, and I'm not sure that you're required to do box diagrams, your first 2 are S's, then you've got a P. Remember, put 1 electron in each box before doubling up. Here comes your 4s2, and then your 3d10. Remember, put 1 in each box. So you've got 3 electrons there, 1 in each box. Now, what happens if something had a charge on it? So let's say that the oxygen had a 2- charge. If something has a charge on it, you just add more electrons in because electrons are negatively charged. So if you get a 2- charge, you add 2 electrons in. If you have a positive charge, start subtracting electrons. Hey, I want to go back. You're not going to have to know this. So this diagram here is not important. Now, if you want to know how many orbitals that you have, it's N2. So if you're on the second energy level, square it, you have 4. 2 squared 4. Right. If you want to know the number of electrons you have in any orbital, so if you're in the third orbital, square it. 3 squared is 9 times 2 is 18. That means on the third energy level, you would have 18 electrons. Do you know what you learned in grade 9? You learned that you had 2 electrons in the first energy level, 8 in the second. Those two things are true. Then you learned you had 8 in the third energy level. But that's because that's where we stopped looking at elements in grade 9. We now know that we have 18 there. So instead of 288, it's actually 2818. Folks, electron configurations. You should know how to use this filling chart that I showed you how to use. There's other ways of doing this. It was the simplest way I could think of showing you. You should know that there are 3 types of orbitals, S, P, and D, and that these can have suborbitals or smaller sections. Each suborbital can hold 2 electrons, regardless of whether it's a P or a D. So the P's have 3 suborbitals, the D's have 5. Maximum number of electrons in the S are 2, in the P in 6, in the D in 10. You should know how to do electron configurations when we have charges, and you should know how to do box diagrams. I believe that's the important part there. My next video is going to tackle quantum numbers.